In this lecture, we're going to see how we can set up static member variables in our C++ program. We have seen that static member variables are variables that are not really attached to any class object. They are attached or tied to the class blueprint itself. And we have seen that they are really useful in that, for example, they can allow you to keep track of how many objects for your class are created. Let's see how we can create them. Here is a simple example. We have our class point, and we have a few member variables inside. But the member variable of interest here is the mPointCount member variable here. Its type is size t, but notice that we have marked it as static here. What this is going to do, it's going to tie this member variable to the class blueprint itself. The member variable is not going to be tied to any point object, but any point object is going to have access to this member variable. But the lifetime of the member variable will be tied to the class blueprint itself. In fact, static member variables are even initialized before you create any object for the class. This may sound counterintuitive, but I am going to show you this in a minute when we head to Visual Studio Code. For now, just know the syntax of our static member variable. The syntax is this. You prepend the static keyword to the declaration of your member variable, and from that point on, it's going to be a static member variable. Now, you see that we haven't really initialized our member variable here. So now it's probably going to contain some junk, and we don't want to do this. But C++ doesn't allow initializing static member variables like this in the header file. So if we use a pair of curly braces after this and use braced initialization, we're going to get a compiler error. What C++ allows is to go in some CPP file and initialize this member variable. And the linker knows to go and hunt for this initialization in any translation unit that you have in your application. The syntax is really simple. You say the class that the member variable belongs to using this scope resolution operator, and then you say the variable name. After this, you can then use curly braces to initialize your member variable to whatever it is you want. This is going to set up our static member variable, and we can use it in our C++ program. Again, note that static member variables are initialized before your program runs. In fact, they are even initialized before the main function gets to run. Because they are special in that way, they are not tied to any object, so they need to be initialized before any object is created in C++. And we're going to try and prove that when we hit Visual Studio Code in a minute. But before we go, I want to introduce you to a new function or member function we're going to introduce in our class point. It is going to be a function to compute the length of a line, and a line is going to be made up of 2 points. So we're going to use this formula you see down here, and we're going to take the x position for the second point and minus the x position for the first point. We're going to elevate that to the power of 2 here, and we're going to do the same computation on y, and then we're going to do a square root of the result that we get inside here. So this is how we can compute the distance between 2 points, and we're going to do that in our C++ program. This is one way I thought of we could make our points a little bit interesting, because what we have been so far can really be boring. Knowing what we know about C++ now, we want to make things a little interesting. Okay, so this is a possible representation of 2 points. We have the origin point, which is at the address 0, 0, and then we have a point, for example, which lives at an x position of 10 and a y position of 5. Suppose this point here is at x of 10 and the point here is at y of 5. So if we go like this, this is going to be the coordinate of our point. But what we want to do is to compute the distance between 2 points. So we want to do something like this. And know the distance between this point here and this point here. And the formula to do that is what we see here. In this point, what we're going to do is treat the 10 here as our x2, and the 0 here is going to be our x1. Then the 5 is going to be our y2, and the 0 here is going to be our y1. Then we're going to do the computation, and what we will get is going to be the distance between these 2 points. This is a formula you can use. And translating this in C++, we can do something like this. So we're going to use the square root function we have in the C++ standard library. So this is basically going to be our square root. And then we're going to take the x position for the second point and minus the x position for the first point here. And then we're going to elevate that to the power of 2. We're going to do the same computation for y, and that's what we have here. And this is going to give us the distance between 2 points, and we can do this in our C++ program. So now that we know this, let's head over to Visual Studio Code and play with static member variables. Okay, so here we are in our working folder. The current project is static member variables. We're going to grab our template files pretty quick. We are going to put them in place, and we are going to open this in Visual Studio Code by dragging and dropping like we always do here. This is going to open our folder. We're going to open the main CPP file, and we're going to clean it up a little bit. Let's do that. We're going to create our files for the point class that we are going to use here. We're going to put in a header file, point.h, and we're going to put in a CPP file, point.cpp. We are going to go in our header file and put in our class. I am going to put it in because I don't want to watch me type all these things. We have our include guards on top, and we have the end of our include guards. And inside we have a bunch of constructors in here. We see a 2-param constructor. We have a 1-param constructor that we can use to construct a point which has the same x and y coordinates. We have a default constructor, and we have a copy constructor. We also have a destructor, which is really not going to do anything because we don't have any pointer member variables in here. But if you happen to have any pointer member variables and you are doing some dynamic memory allocation in the constructors, you're going to use this destructor here. But we're going to put it in here just to be complete. So down here we have the meat of this example here. We have a static member variable. This is going to be a member variable whose association is going to be with the class itself. It's not going to be associated with any class object. But we're going to prove this in a minute. For now, let's head over in point.cpp and try to implement many of these methods. I think we can actually grab them all. Let's do that. We're going to grab them all here and do them all one by one. And I would challenge you to try and implement these things yourself without watching anything, because you already have the tools to do that. So we're going to include point.h, our header, and then we're going to implement this constructor here. So we're going to put in our scope resolution operator, and we're going to do our initializer list. Our member variables are called mx and my, so we're going to do that. We're going to say mx is going to be initialized with x. Let's use braced initialization here. And my is going to be initialized with y. Let's do that. And once we have this, we can jump into the body of our constructor here. And it is already done. It is initializing our member variables. Let's do the second one. So we're going to put in our scope resolution operator. And for this constructor, we are going to delegate the construction to the first constructor we did here because we don't want to repeat ourselves. So what we're going to do is delegate to the other constructor, and we're going to give it xy coord in the position for the x coordinate, and this is going to do what we want. And then we're going to implement this constructor here. This constructor is going to be initializing our member variables. The member variables are called mx and my. So let's go down here and put in our scope resolution operator. We're going to say point, and then we're going to use an initializer list to initialize our member variables. We're going to say mx. We're going to use braced initialization here. So we're going to say x, and we're going to say my and put in our initializer to be y here. It's not x. And then we're going to put in our body, and our constructor here is basically done. Now, the remaining constructors here will be delegating the construction work to the constructors that we just did here. This is going to avoid us to do the same job in the body. This constructor here is going to take over that heavy lifting, and the others are just going to be using it. The way we do that, we're going to use constructor delegation. You already know that, so let's do that here. And we're going to delegate to that constructor. We're going to say point, and then we're going to pass the x and y coordinate. This constructor here is a single parameter constructor, which is going to pass the same value for x and y. So we're going to use our parameter here. We're going to say xy coord for the y coordinate, and then we're going to go in our body. This is not auto-completing because we didn't say that this constructor is from the point class. We forgot our scope resolution operator. Let's do that pretty quick, and all these squiggly lines should go away in a minute. Let's wait. Okay, they're not going away, but if there's a problem, we're going to figure this out. We're going to do the other constructor here, which is a default constructor. We're going to put in our scope resolution operator, and we're going to grab the comment here and put that on top. I think this is going to do. Let's align this properly. And we're going to put our initializer. It is going to be delegating to the other constructor, and we're going to put in default parameters we want to use. We're going to use 0, 0. Let's do that 0.0 because it's a double. And then we're going to do the body. Okay, so this constructor here is done. Next, we're going to do our copy constructor, which is going to be doing member-wise copy. It's not going to do anything special because we don't have any pointer member variables. So this is going to be basically the same thing as the default constructor that is generated by the compiler, but we want to do it ourselves. So let's delegate, and we're going to say point mx, and we should use brace initialization here. I am mixing things up. So we're going to say point mx, and then we're going to say point my, and we're going to put in our body. This should do what we want, and we need the scope resolution operator here. Let's do that. And the destructor is really not going to do anything. So we're going to put our scope resolution operator, and we're just going to put a body. Let's do that. We're going to take out this comment, put that on top a little bit, and we're going to align here, and we're going to put the body in here. And the remaining function here is going to compute the distance to the origin. And we have seen the formula we can use to do that. So let's go down and put in our body. And this function is going to belong to the point class. We're going to tell that to the compiler using our scope resolution operator. And we're going to move our return value before the scope resolution operator. Let's be careful about this. We are going to go on top and include the math library from the C++ standard library. We're going to grab CMath. And then we're going to go down and put in the body for our function here. And it's basically going to return the distance between the current object, which is the current point, to the origin. Again, if you have forgotten, this is the formula we use to compute the distance between points. Our point is going to be this point here, and we're going to be computing the distance to the origin. And we're going to get that as a double value. Okay, so by now our functions should be all implemented, and what we can do is try and build this program and see if we don't have any problems. Let's use GCC for that. We're going to build with GCC, and we're going to have a problem, and it's going to say xy not declared in this scope point CPP at line 9. Let's go there and do that. Xy underscore coord. This is the problem here. We're going to fix this, and then we're going to try and build again. Now the build is good, our class is working, and we can create objects of this class and really see that the memory locations for the member variables are different from different objects. So to really see this, we're going to put in a printful function. We're going to make it public, and we're going to say it's going to be const because it's not going to modify this class here or the member variables from this class. And we're going to say stdc out point, and we're going to say address of mx. That's what we want to print here. And we're going to put a comma here and say address. That's what we want to see. And we are going to print this out. We're going to say address of my, and we're going to put our closing square bracket. I think we should put 1 here. We don't need a colon here. I think this is going to be better. And then we're going to put our new line character. Now we can head over to main and really play with this. We're going to include our point class, and we're going to go down and create 2 points. We're going to say point P1, and we're going to put in 2 values, 10 and 20. Why not? And we're going to say point P2, and we're going to say 21.8 and 40.6. Why not? And then we're going to say P1 printful. We're going to print the information, and P2 printful. Okay, so let's build. What will we see when we print this information? We're going to see the addresses for the mx and my member variables for these objects. And what we want to prove is that each object is going to have its own member variables, and they are going to be completely independent of other objects. So let's build. We're going to build with GCC. And if we go up, you see that the build is good. Now we can clear and run Rooster. If we do that, you're going to see that. Okay, so you see the output is saying DD0 for the mx member variable for the first point, and it is saying DD8 for the second member variable of the first point. If we go to the second point, you see that we have DC0 and DC8. You see the addresses are different. So the member variables are completely different because they live in different memory locations. So this is working fine if you want variables to be constrained to objects. The default way we have to set up member variables is going to work. But if you want member variables to be associated with the class itself, you're going to need to do something else. And to be able to achieve that, we will have to mark our member variables as static. So we have a member variable which is static here. Its type is size t. The name of the variable is mPointCount. So once you have it declared like this, the variable is not going to be properly initialized. If you want to initialize it, you will have to do it in a CPP file. Because if you try to do that in the class definition like this, we're going to get a compiler error. C++ doesn't allow this. Okay, so you see we do this, we get a squiggly line. If we try to build with GCC, let's do that. We're going to get a compiler error, and the compiler error is saying in a class initialization of non-const static member, point here is not allowed. This is what the error is saying here. We're not allowed to do this. If we want to initialize our static member variable, we will need to do this in a CPP file. And we can really do it in any CPP file, but we have point.cpp here, so we can just do that here. We're going to say initialize static member var. And the way you do that, you say the class where the member variable belongs, and then you're going to say the name of the member variable, and then you're going to initialize it with whatever you want to initialize that with. Let's say we want this to be 0 by default, and we're going to put a semicolon here. And in front, we need to say the type of this thing. So it is of size t type. And this is the syntax we use to initialize static member variables. If we do this, this is going to be properly initialized. Now, we have our static member variable. It is initialized in a CPP file. How do we use it in our C++ program? Well, because this guy is public, we can really use a convenient syntax to access this. We can even access this before any object is created for point. So let's go back in the main CPP file and really try to do this. We have already used these points. I don't think we need them anymore, so we're going to take them out. And we're going to say print the point count in our program. And we are going to say stdc out like we say always, and we're going to say point count. And notice the syntax we're going to use. We're going to say point and then mPointCount. This is going to give us direct access to our static member variable, and this is really cool. Notice that we are able to do this before any point object is created, and this is really cool. This proves that the static member variable is initialized even before the main function runs, because this is what C++ does. We are able to get to the point count before we even create any point object. Notice that no constructor has been called. We didn't set up any point object in main. We just print the point count. And we're going to see that if we print this, we're going to get 0 because that's what we initialized our static variable with. This is really cool. So let's try and build our program. We're going to use GCC to do that. You see build finished successfully. So this is cool. We can clear and run rooster. Point count 0. We are able to access our static member variable, and it is attached to the class itself. It's not attached to any member variable. Now, let's try and change what we initialized this guy with so that you really believe that this is going to come here, the value we print. We're going to build again. Let's use GCC, and the build is good. We're going to clear. If we run rooster, we're going to see the value we initialized our static variable with. And this is what static member variables are really about. They are variables that are attached to the class itself, and they are not attached to any object of your class. Now, let's use this member variable to really do some cool things. We are going to go in our heavy lifter constructor and any point, and after we create any point object, we're going to increment our static variable to properly keep count of how many point objects we have in our program. So we're going to increment mPoint count, and whenever the destructor runs, our point object will die, so we're going to decrement the point count. So we're going to go in our destructor and we're going to minus mPoint count. And now we have the option, and now we have the capability to really get how many points we have created in our programs. We can print the point count here. It's going to be 0 because we don't have any point object created. But now we can create a new point object. Let's put in 10 and 20. And if we print the point count again, we're going to see that we're going to get a 1. Let's do that. We're going to build with GCC. The build is good, so we can clear and run rooster. You see, point count 33. Why do we have 33 here? Oh, we need to go back and change what we initialized our point count with. So we're going to initialize this to 0. And then we're going to run. Why aren't we incrementing here when we call our constructor here? Let's say point constructor called here so that we know that the constructor is being called. And we're going to pass double parameters here. Let's make sure we pass what the compiler expects. So we're going to pass 20.4 here, for example, and then we're going to build with GCC. The build is going to be good. We can clear and run rooster. Now we see that the point count is 0. Why is this? After we create a point here, we're going to increment point count, and we should get a 1 after we do this. We can print the point count here, and we're going to get 0 because at this point we don't have any point object created, but we can create a point here. We're going to say point P1, and we're going to put in 10.0, for example, and a 20 point. And if we do this and print the point count again, let's copy this, and we're going to put this down, and we're going to make this a semicolon, not a colon. And if we try to build, we're going to see that here we're going to get 0, run, but the moment we hit this point here, we're going to initialize, but the moment we hit line 9 here, we're going to create a new point object. This is going to call our constructor here, and it is going to increment mPoint count. If we print this, we're going to get a 1. Let's be sure that our constructor is really called. So we're going to say point constructor called. And this is the constructor that is going to be called regardless of how we build our object, because all the other constructors are delegating the work to it. You notice this is what we are calling for any constructor that we have through constructor delegation, and this is really cool. So if we print here, we're going to get a 0, and if we print here, we're going to get a 1. This is what we expect. Let's build, and we're going to build just fine. The build is good. We can clear and run rooster, and we're going to see that for the first time the count is 0, now point is 1, and this is really cool. We can set up an array of points. We can do that. Let's say, for example, point, and we're going to say points, and we're going to put in a pair of square brackets, and then we're going to initialize this with a pair of points. Let's put in, for example, 1, 1. We can really do whatever we want with this. We're going to put a point here, which is going to call the default constructor. Notice that we are building these guys in place. You can really do this if you want. And then we're going to put another point, which is going to call the one parameter constructor. And we're going to put in 4. Why not? Now, if we print the count for points, we're going to get a good number for points. We have P1 here, which is our first point. We have 2 points, 3 points, and 4 points. So now if we print, we expect to get a 4 printed out. And hopefully this is going to prove that we are really keeping track of the points that we create in our C++ program through the help of our static member variable, which is really not attached to any object we create in the main function here. It's just attached to the class itself. So we're going to build. Let's use GCC to do that. The build is going to be good. We can clear and run Rooster. Now you see that we have a few constructors called 4 times, and each of these constructor calls is going to increment count by 1. And when all these points are created, we're going to have 4 points in total. And this is really cool. Okay, now that we have really played with our static variable, I wanted to make it super clear that it is possible to really initialize this static variable in any translation unit or in any CPP file to be exact. Let's go on the left here and create another CPP file. So we're going to hit the add new file button here, and we're going to say some other file, and we're going .cpp. This is going to be a CPP file, and it is in the wrong folder. So I think we can grab this and bring it out. Let's see if this works. And we have the file here, and we can grab the initialization of our static variable and really move that there. So we're going to save this, but to make this work, we need to include the point class, because at this point, this line here is not going to make sense to the compiler, because the compiler is not going to know what point is. So we're going to include point here. And the moment we do this, now the compiler is going to know what point is, and it is going to initialize the static variable that is declared in our class here. So notice that we don't have this initialization in point.cpp anymore. But if we build, this is going to build just fine. Let's build with GCC. You're going to see that the build is good, and we can clear and run Rooster, and we're going to get the output that we expect. Another thing I want to be super clear is that a static variable doesn't belong to any object, and we can really modify our static variables if we want in any const member functions. So this is going to be counterintuitive, but note that it is possible to modify the static variable. Remember, the const keyword after a member function is going to prevent you from modifying any member variable in the class or in the object, because member variables are associated with objects. But a static variable is not associated to any object. It belongs to the class as a whole. So the const keyword in your member function is not really going to protect it. So to prove this, we're going to go in our const member function here, and we are, for example, going to increment mPoint count. You're going to see that this is going to build, and some of you are going to say, what are you doing here? You are trying to modify a member variable. But this member variable doesn't belong to any point object. It belongs to the entire class as a whole. The const keyword here is going to prevent you from modifying any member variable that belongs to the object. And when I say object, I mean object like P1 here. So if we go down here and, for example, say point1 get point count, just calling the function here, we're going to hit the body of this function, we're going to increment, and then we're going to return. If we try to print what we return, let's say size t result, and assign that to, and give that the value we get from our function call here, and if we try to print that out, we're going to get a 5 because we have already changed our member variable through the call to this function here, get point count. I really hope you understand this. We're going to build, and the build should be good, and if we print result should be 5, and it is a 5 here. And if we print the point count through the syntax we used here, let's do that. We're going to put this here. We're also going to get a 5 because this is the same variable. Let's do that. We're going to build with GCC. The build is going to be good. We can clear and run Rooster. Now we have a 5 here, and this is really cool. Now, if you go back in our class, you're going to notice that the static variable is in the public scope. And I did this on purpose because I wanted the syntax here we have used, saying point, colon, colon, and point count, to access the static variable before any object is created work. I wanted this syntax here to work. But if you bring your static variable in the private scope, let's try and take this out and put this back together with the other variables. We're going to go back in main and we're going to see that this is no longer working. The syntax here is only going to work if your static variable is living in the public scope. If you don't have it in the public scope, you can access that through any function or member function that is returning that. Let's take out this call here because you already know that you can modify static variables in const member functions. So now we can have access to our variable through the member function here. If we want, we can do that. So let's go back and really fix this. We don't want these compiler errors. So we're going to comment this out because at this point we don't have any object created. But the moment we have an object created, we can go through the object and get how many objects are created for that object. So here we're going to say P1 get point count. We're going to call the function here or the member function. We can take this out because we don't need this anymore. And down here we're going to say P1 get point count, and we're going to print that. For the first call here we're going to get a 1. Oh, we're going to have a 4 here, and we don't need the second one here. So let's take this out. If we do this, we're going to get 4 printed out because we have 4 points created at this point here. We can copy this and go on top here and paste this in place. And at this point, we're going to see a 1 printed out because we only have 1 point created. Let's build and really see this in action. We're going to use GCC. The build should be good. We're going to clear and run Rooster. Now we have point constructor called. We have 1 point. We're going to call the constructor 3 times because we have 3 points stored in our array here. And the total point count is going to be 4 as we see here. And we are going through the syntax here. So again, the message is if your static variable happens to be living in the private scope of your class, you're not going to be able to use this syntax here to get access to your static variable. You have to go through some function to get it if you really want that. This is the message here. Okay, I think this is really all I had to share in this lecture, raising your awareness about static variables. It should be clear that static variables or static member variables belong to the class as a whole. They don't belong to any object of your class that you create. We have seen that we can use this syntax here to get access to static member variables if they happen to live in the public scope of our class. And if they live in the private scope, you have to go through an object and use some member function that returns the static variable, and that's going to work also. We have seen that it is not possible to initialize your static member variable inside the class. If you try to do that, you're going to get a compiler error. If you want to initialize that, you will have to go in some CPP file. And here we are doing that through a CPP file called some other file. And the linker is going to pick up this definition or initialization that we have here, and it is going to work. This is really all I had to share. I hope you found this lecture interesting. We are going to stop here in this one. In the next one, we're going to see a technique introduced in C++ 17 to allow us to initialize our static member variables inside the class declaration if that's what we want. So go ahead and finish up here and meet me there.